I think it's that time. For what? Another episode of your Re-Educated podcast. Welcome back. It's your host, Gautam Yegapin, alive and blessed to present you with today's conversation. Stay thirsty for knowledge, and I guess some water too. As today, we have an extremely special guest, Alexander Karp. He is a professor of mathematics education at Teachers College, Columbia University, internationally respected for his work on the development of mathematical reasoning, curriculum design, and the cultural influences on mathematics instruction. His work integrates perspectives from cognitive science, psychology, historical analysis, and comparative education to explore not just what mathematics students learn, but how they learn it and why educational systems teach it in the way that they do. His scholarship deepens understanding of mathematical thinking across different age groups, educational contexts, and national traditions, while his teaching prepares the next generation of researchers to bridge theory and practice in mathematics education. How are you doing today?
Hello, thank you for inviting me. It's a pleasure to talk about these issues. And yes, let me say that probably today my major field is history of mathematics education, but generally speaking, I'm interested in problem solving and gifted education. Some psychological issues and issues of general development are, of course, also among my interests. All these things are in this or that way connected, of course. Thank you.
I mean, I love starting with origin stories because it's always nice to know how people found the interest in what they're doing. What was your early relationship with mathematics like that led you to kind of be much more fascinated by understanding the history of it and the social approaches to understanding it?
Well, my colleague always said that what people really like is to start say now briefly about myself, and then for 2 hours tell about their life. So no, I will not go into this, but I always was interested in two things, in two directions, in history and in mathematics. And eventually I went into mathematics education, and although I also studied history, and then I went, so I was lucky, I was privileged in some way. I started my career as a teacher in the school. I'm from Russia, from St. Petersburg, in Leningrad then, and I started my work as a teacher in school. These schools were in Soviet Union called schools with advanced teaching of mathematics, or advanced course of study in mathematics. In the States, they are usually translated, the name is usually translated as schools for mathematically gifted. I'm not fond of this name. I think that gift is something about which we can say substantially later. But what we can say immediately, that people are interested and successful. So this school was for children who wanted to study mathematics more. And yes, that raises a lot of questions, how to do it, what are their problems, and they have, of course, educational problems too. And step by step, I started writing about this. I wrote some books, collections of problems. For children, I was involved in teacher education, and basically also started doing some history of mathematics education. And that's what I continued doing when I moved to the United States, which happened already more than a quarter of a century ago. So it's already many years that I'm doing more or less the same in this country. So that's my trajectory.
So cool. I mean, it's funny. Collection of problems, which I'm really excited to get into to kind of understand what that is. And, it's really interesting because I think something that can often happen in relation to education is we can feel like the current systems that we're experiencing now are what it's been forever. And it kind of helps us make sense of it because it creates this sense of like, oh, okay, well, it can't change. It's always been like this. But I think one of the most beautiful things about history is the strong reminder that things always change, that what things are today will not necessarily be the same way in 100 years and even 50 years. And so that makes it a little bit, I think, that I always feel like that's a sign for optimism or hope, because you as a human, you kind of have a say in how that goes and where that goes. And so it is really interesting to maybe even start with the history of math education. Well, I guess one of the questions that comes up to mind first is, when you talk about the history of math education, are you talking more particularly in the United States context, or is it more of like a worldwide phenomenon? Like, how are you looking at mathematics?
Okay, thank you for your questions. Actually, yes, there are many things to, you asked many questions, and there are many things to discuss. First of all, I'm interested in the international history of mathematics education. And generally, I believe that's an interesting and important thing, that you cannot understand things happening even in the United States or in smaller country without, or larger country like, I don't know, China. I mean, in terms of population. You cannot understand if you don't look around. Today people like to say, oh, globalization, connections, all these things. Of course, connections became substantially easier. I'm in New York now, you are in San Francisco, and we are talking and communicating, which could not be done 200 years ago, or even 50 years ago. But at the same moment, it does not mean that people were not connected, and mathematics education was isolated. It really was not, in different ways, but it was. Now, regarding the idea that things are changing or not changing, it's a very popular but absolutely wrong understanding that in mathematics we are studying same things. And I studied sine of 30 degrees, and my parents studied, and great-grandparents, and so on, until basically I don't know whom in prehistoric time. No. And it's not only because, say, all these things I mentioned, trigonometry, but trigonometry in somewhat close to current school form emerged, let's say, less than 300 years ago. I mean, not trigonometry as used in some other fields, but as taught in school. But there are much more important things. You mentioned problem solving. Today, the word problem solving is the most popular word. It's today, you will never find any person who would say, I'm against problem solving. It's not possible. But what is important, that everybody understands what is problem solving in their particular way. And yes, there is some scientific terminology, but there are some, let's say, disagreements. But in any case, what is absolutely clear, that this idea that in mathematics, what we are doing in mathematics, we solve problems. This is a new idea. What do I mean new? Of course, it's not today. But it's, let's say, a bit more than 100 years ago. Among other things, I am exploring international movement, international reform movement, one of the leaders of which was David Eugene Smith, very important mathematics educator. Basically, in some sense, he's a founder of many things. In particular, he was a founder of the program in which I'm now working. But he also founder of many things in international mathematics education. But what is important? Under his leadership, there was American subcommission, so-called subcommission of International Commission on Mathematics Instruction. And they prepared a report, very important document. And so in this document, I think in 1911, they wrote explicitly, 50 years ago, there were almost no tasks and solving exercises and problems in mathematical textbooks.
Wow.
And if you open, it sounds today for us it's crazy, but if you open textbook, well, not arithmetic was a bit different, but say you open geometry, you will find that there are just very few problems. For the entire course of playing geometry, it could be, 20 problems, 30 problems. And it's not American phenomenon. If you look, say, in Russian textbook of the same time, it was exactly the same. The idea was not that students are solving problems, but the idea was that they learn wisdom. And wisdom, they did very sophisticated things, which today we would say, what for are they doing? But they list, by the way, in this report, they list some things. Why do you need it? You'll say today technology is doing many things, but even without technology, but just you show some wisdom. And then, step by step, people started thinking that what you need, it's not just enjoy from philosophical point of view. Look how beautifully it's arranged. But you need to develop ability to do something yourself. And it's an interesting story. How did it happen? What were, let's say, social reasons behind this? And all these things connected with what became more or less clear at some moment, developmental role of mathematics, that we are studying mathematics in particular to develop some thinking. And note that people always agreed that later that we are doing it. By the way, you said that fact that things are changing produces some hope. To some extent, yes, but we should not think that everything is improving. This beautiful line of progress that today we are doing better than yesterday, and tomorrow we will do even better, unfortunately, it's not always true. Not always true in mathematics education and in education in general in particular. But the process is going, and it's very interesting to understand how it is going and what are reasons.
Yeah, I mean, I think the examples that you're giving are really interesting because this idea even of first separating between arithmetic and then the rest of mathematics, I feel like is a really important distinguishment. When we speak of mathematics, then are you talking about geometry, algebra, pre-calculus, and then arithmetic is learning multiplication, addition? Is that how you're making that? Is that how you're separating those two?
Oh, let's say like that, yes. Mm-hmm.
Yeah. And so when you talk about these geometry textbooks, I mean, they sound so fascinating. I'd love to look at one. Are they more proof oriented? Like, how is it that they're teaching wisdom necessarily through the lens of geometry?
Look, you see, if we go to, let's say, history again, not relatively recent history, which I'm doing 300 years. I'm mainly interested in the period after, let's say, basically I could say even after French Revolution, but okay, since 18th century. But if we look much earlier, you will find that when ancient world collapsed, what they left to Europe, let's say accurately to Europe, it was basically philosophical attitude towards mathematics. And mathematics in general was a part of, let's say, philosophical list of philosophical subjects. It's famous trivium and quadrivium. And that is parts which were studied and arithmetic and geometry and another, we would say, mathematical subject, astronomy, were studied as a part of second part of philosophy. That automatically means that very few people studied it. But they studied it, let's say, from philosophical point of view, and not just exploring some properties and finding some characteristics which today we probably pay less attention to. If you look, say, in classic ancient philosophy like Plato, you will see that, of course, mathematics is extremely important for him. And their dialogues, when you discuss this famous dialogue when Socrates discusses the property of a diagonal of a square, and that's basically what is today mentioned in school, that the square root of 2 is an irrational number. But it's some characteristic of the world. And yes, people studied in medieval universities, these studied mathematics as, let's say, kind of religious subject connected with philosophical issues. But simultaneously, there was developed another attitude, because mathematics was also a very practical subject. And we understand when we look at in any medieval city, we look in the center stands a cathedral. And we are thinking, how did they make it? So if you are making a building like this, you need to know a lot of mathematics, and some physics. Otherwise, you simply cannot. It's not just by trial and error. Look, let's cancel. Oh no, it's collapsed. Let's do again. They had some knowledge. It was probably expressed differently, but basically they had it. We know not too much, by the way, about how they were prepared. Clearly, it was different. There were families in which some knowledge was transferred. Then we came to a period when more mathematics was necessary, say because of development of navigation, because of development of artillery, because of constructing fortresses. And what basically happened, that these two sides of mathematics, more philosophical and more practical, eventually they got combined. And that's how we basically received secondary school mathematics as we basically had it second part of 19th century, for example. But of course, this culture of discussion, it basically goes since, if you wish, Plato or even earlier. So yes, philosophical.
Yeah, I think it's interesting because I studied math in undergrad, and I feel like the things that you're saying, I only can relate to because I studied it in undergrad, and I was able to kind of be in spaces where mathematics became so much more fascinating. And if you had talked to me, if I had never studied math and I studied something else, the things that you're saying would be so foreign to me. I wouldn't even be able to connect with it. Where I'm like, I feel like for a lot of people, the experience of mathematics is so rigid. It really is just regurgitation, formula, memorization, where the reasons why anything is the way that it is kind of, it's not something that's highlighted at all. I think one of the most beautiful things about math in a lot of ways is that it teaches you how to reason and to really ask one of the most fundamental questions of all of science, which is, what does it mean for something to be true? And how do you actually go about understanding what is and isn't true? And that ends up showing you how all of knowledge is kind of constructed upon. And I think there are so many more profound questions that exist in math. So would you say that prior, these types of questions were what people were talking about?
Well, there was, of course, some process. I would agree with you that mathematics plays a special role in some development of attitude and thinking. There was one very important Soviet Russian mathematician, Alexander Alexandrov, and he wrote that he was involved in school education, wrote a textbook, but for secondary school. But he wrote that mathematics is the only one subject in school where truth is established right there in the classroom. It probably was a bit too strong because, say, in physics or chemistry, you also can conduct an experiment and see, okay, you see, guys, we thought whether these things will fall down. You see, it did. Yes, truth is here. But it's very often not like that. While in mathematics, you can do much more right and left. It's another story whether you are doing it or not. And here is indeed a very serious problem. What are we teaching and what for? Yes, you see, if you look, there were different periods. As I said, it's not just one line. Clearly, I said that we know not too much about, let's say, how medieval experts were prepared, but it's probably questionable to what extent they proved some things in classes. Probably in many cases it was just a recommendation. If you want to do something and something, do this and this. We have some books, coincidentally, just yesterday I discussed with one colleague, one book which actually was translated from German into Russian, and Russian Tsar Peter the Great, Peter the First, to some extent was involved in the process. We discussed how much he was involved. But what is there? It's called Tools of Compass and Straight Edge. Tools of Geometry, Compass and Straight Edge. And they are given some recommendation. If you want to do something, do this and this. Why? Why will it work? No explanation. But step by step, we came to school, came to the system in which there were a lot of accurate reasoning. And of course, in, let's say, 1910, for instance, in American high school, there were not too many high schools, not to say German gymnasia or French lycée, they required a lot of reasoning. Then, what has happened? There was another movement. And people said, look, what for? Why are we wasting time for telling students all these things that if you do this, then you do that, and then you will see, and all these things. While we need to explain people how to apply these things. Engineer needs it in practice. Let's show it to him. Let's do much more application. It was a very strong movement. Parallel to this, there were some educational movements, say, located, interestingly, in this very building at Teachers College. And the result was that less proving, less reasoning. Some people said a normal people does not need algebra. Algebra is for very few people, mathematicians. Okay, let's do it. But normal person doesn't need it. It was a sophisticated process. I'm not saying that this approach materialized, but neither approach with a lot of proving and a lot of reasoning is indeed in school. And you will ask, and basically there should be, let's say, some balance. Not that I want to say that we should not discuss at all applications. But I think that this balance, in my opinion, in reality today, of course, much more about this style of receipt. Just go, just you see, if you want to prepare something, put 300 grams of this, half pound of that, boil it, and you will receive something. And that's, of course, very wrong. And yes, I would say it's one of our major problems today, speaking not about history, but speaking about reality. Yes, I think it's very damaging for students, for nations.
Yeah. I mean, can you maybe expand on why you feel that way? Because I think I definitely do. But why is it that because for a lot of people, because when you take these mathematics tests, for example, which is what people compare, like the US is falling behind compared to all these other countries, we're not doing so well. Those are all not really focusing often on reason, but purely just application. So can you memorize how to do 3x plus 5 equals 12? Do you know how to solve for x? If everyone can do it well, we're doing great as a country. So the tests itself that oftentimes people kind of value don't seem to be caring so much about reason. So what is it, do you feel, that the reason really brings? Why is it important in mathematics?
Okay, you see, the topic which we are discussing is very broad, and you brought this international assessment. We can separately say about them. Basically, it's very human. People love it. Just, you see, you look at some table, our team is on place so-and-so, and this terrible whoever are doing better. You see, it's very difficult to compare, and you see, given that it's a place for the country, and people love these things to compare United States with Singapore, although, here is some minor things that Singapore, as far as I know, is a little bit smaller than United States. So you see how so all these things, there is a lot of funny things. But you see, the point is, I generally believe that mathematics is important in some, let's say, attitude to knowledge. To general, and that's probably the thing which is not always clearly understood. People are saying very often today that mathematics is, when people ask it, "When why should I study mathematics?" People say, "Look at your telephone. Look at your telephone. Do you know that to do this or that, such and such functions were used, and you need to know a lot of mathematics to do telephone." Yes, that's exactly correct. But it's not true that all students in my class will do telephone. No, it's not the case. So I need to ask him, what for? Mathematics is important for this boy who later will become, I don't know, translator. That's a very important question. I thought about it because, you see, I authored a textbook which originally was intended. I mentioned that I myself worked in school with advanced teaching of advanced course of study in mathematics, but there was a moment when there were schools, officially they still exist, but it's another story, schools with advanced course of study in humanities. One of the beautiful things about humanities was that there was short course of mathematics, shorter than in regular course. But the question still was, what should you do there? And some people believe that what you need to tell stories. And they're beautiful stories like, do you know that something works due to mathematics? You can tell a fantastic story. I know one guy, he's a very serious mathematician. He told me once a beautiful story. I said, you need to publish, but as I know, he did not. The story was, let me tell it, I like it, and I think it's helpful for our discussion. He was going somewhere by plane, and he had with himself, fighter for how it's called, to lighter, of course.
Yeah.
Lighter, lighter, because he is smoking. And system immediately recognizes that he has it. Okay, very good. He put it somewhere. He knows how to do it and put it again. No, they still recognize. No, okay, he had to throw it away. But a little bit later, in several months, he had in his seminar, and again, he's leading some seminar, he had some presenter, and presenter was talking that they developed a new system of checking in the airports. And he basically understood that it became possible because he himself invented some mathematical thing. So he lost his lighter because he himself developed some mathematical instruments. Interesting story. But if you just tell only stories, it does not help your development. And my general belief, it's not just mine. I, interestingly, several days ago, was talking with students about psychological issues, and basically it's a major contribution of great psychologist who is always cited in educational literature, Lev Vygotsky, who wrote that kids have two kinds of definitions in their life. One spontaneous or everyday definition, They just know they meet something and they learn that that's how it's called. Child meets another child with a woman who takes care of him. And this woman is called mother. So mother is a woman who is taking care of another little boy. That's a definition he learned from life. But there are also scientific definitions, which students learn in school through instruction. And what Vygotsky says, that both have some issues. And with this everyday definition, children, of course, in process of development, they cannot do more advanced form of reasoning. And say, with the same mother, he cites a child who said about some gentleman and woman, he said, he formerly was her son. And when people said, what do you mean formerly? Isn't he her son now? Of course not. He's so mature. Because for this child, son, it was a boy with a woman. So the boy is called son, the woman is called mother. That was his everyday definition. So doing something more advanced was difficult. On the contrary, scientific definitions, people can do logical reasoning, some other things, but they are not quite good in identifying them in real world. So translating them to real. And according to Vygotsky, these two processes go simultaneously, and developing from scientific, so mastering scientific concepts helps in developing all other definitions. In other words, if to make this with some examples, mathematics must, I'm not saying that it's doing it, unfortunately, very often it's not doing it. But mathematics is supposed, for instance, it's not only one thing, but mathematics is supposed to teach kids and therefore adults to work with definitions. You are saying something. What do you mean? How does it go? You see, they are in mathematics, we are given some exercises. Like parallelogram is a quadrilateral such that it has two pairs of opposite parallel sides. And then you can give exercises. You can say, wait, and this guy, is it a parallelogram? No, why not? Because it's not a quadrilateral. Okay, what about, you can write this, this? No, because there are no two parallel sides. So you are checking, you are understanding, you are exploring this. And it's not automatic procedure. You'll say that for adult, if you take a student of the college, students will do it. Well, anyway, they will do it even although probably in school they were not taught it, but life taught them. But although it's an interesting question to what extent, and how many, and in which case, and so on. There is one very important American mathematician, Hyman Bass, and he discusses in one of his works, he used it, by the way, he cited it several times, how he discussed the concept of polygon with different audiences, and that's a standard thing, but how will you explain what is it? And people were unable to do it. But what I want to say, that this mastery, this culture of understanding what you mean by this definition, it's used in in everything. And probably it will not be that rigorous as in mathematics, but still. And when today I'm reading you see, I don't want to go into political things, but when today I'm reading people are using this or that words absolutely without understanding what they mean. It just, okay, let's use it. It's wrong. And in some way, I would say that yes, that's most important. Because you see, there is a great question, great fundamental question. What do we want? What for? What is our goal in school in general? And the major answer, I believe, is to get intelligent citizens. So a citizen who can function in democratic state and who supports it, who understands how it functions, and so on and so forth. Because basically, in general, for any system, the most important thing is to provide conditions which support system. That system will not destroy the next generation. And when I think how to prepare this intelligent citizen, yes, teach, understand what we mean by this or that.
Yeah, I mean, I think it's interesting because even with this definitions example that we're talking about right here, I feel like there's two different ways you can approach it. So, for example, even when I feel like English and math and both these subjects became so much more fascinating to me when I realized the definitions for English words, for example, are not set in stone. They're not static. The same word can mean something completely different given enough time, given enough. Words have meaning because we come together and agree upon some sort of meaning. They don't have meaning because it's in the essence of the word, something means something. And so it's a constant contract, at least in English, where we constantly work through the definitions of different words, what they mean in different contexts. And once I understood that, words and language just became so much more fascinating for me. But earlier, I used to think, oh, okay, I need to memorize this word means this. And then I need to then be able to, on the SAT or on some sort of test, be able to basically pick the right word, showing that I am competent and understand it. Which, even though I learned definitions in that sense, I didn't understand the more complex underpinnings behind that, which is that definitions can change. The definitions are something that we have to agree upon so that we can then build arguments. But we can define them in their own kind of how they can vary. We can define things like justice or good or bad. These don't have one sort of stuck meaning. And it's same with mathematics in a lot of way, where when you start understanding the arguments for which each thing is true, you realize how kind of beautiful and complex they are. And things that we once believed were true could be false, and how you kind of get to that point. So even when talking about definitions, how do we separate teaching this type of reasoning between those two? Because you could still approach this kind of reasoning process through memorization as well. You could think, oh, given a proof, there's a way I need to memorize how to do it. I just need to remember exactly what proof it is and then do it again. It feels like there's something underlying that's different, not the actual content itself.
Let's first, let me say a few words about changes. You see, of course, meaning of words in our regular life, it to some extent changes. And understanding can be very different. I said that what is problem solving, people very often understand differently. And they're different. And in mathematics, even although mathematics is supposed to be more, let's say it's a way rigorous with some terminology, but some things are changing and so on. But every time when you are using something, you have some meaning which you have. And yes, it can be that people started understanding some terminology differently. But when they're using, they need to understand themselves. That's what it is. Now, regarding the different things about memorization and reason. First, let's say that memorization, you see, it's a human mind. We like to have some enemy. Be like that, don't be like that. You see, what we mean by memorization. Absolutely every single person memorizes something. And if you ask, you see, I'm usually asking in my class, please raise your hand if you don't remember your social security number. No hands, no hands. Everybody remembers social security. And if you are opening some email which you are using, you typically remember your password. It's another story how this memorization is done and how many things and what for you are memorizing these things. Yes, of course, it's we all remember our address. I live here and although, of course, you could have it somewhere written. But you see, it's working memory. It's like computer. You have it somewhere immediately. But memorization does not work in very many cases when you need to do something further, understand some things. And the fact that you, by the way, whether student, typically good student, is supposed to remember, I don't know, how to prove that diagonals in parallelogram bisect each other. Well, typically good student remember how to prove it. Not because teacher said you sit down and memorize, but because he or she delivered it, discussed it, and basically remembers the idea. And what is valuable here, it's some idea, some track of reasoning, some direction. But that, so it will come, but it's not the way to study mathematics, but it's a product. Yes, you understood the idea, therefore you'll remember. That's how it goes. Unfortunately, very often it's not what is done in school in this situation. And people very often believe that it's quicker and more effective rather than explain why we solve equation like that. It's simpler to say, do one, do two, do three. Here are steps. Let's say all together. First step is, and so on and so forth. People basically, historically, and I'm terribly sorry, even now are doing these things. People will do these things, but it's not learning. They are not going anywhere else. Unfortunately, the reason why it's very often happening is because teachers themselves very often not quite understand what they are teaching. And that is where we're coming to this extremely important question. What and how we should do with teachers and how should we teach teachers. I mentioned David Eugene Smith, founder of our program and to some extent clear leader of American mathematics education for many, many years. And he was very concerned. That's why he created our program, that we need to prepare well-educated mathematics teachers. Is it possible? Yes, it is possible. But as usual, it needs a lot of work and a lot of investment. I mean, all investment, of course, in terms of money, but not only. It's not true that simply if you get somebody will take, please, $10 billion and do it. No, it will not work simply. You need to do many things this way. But that's, of course, would be.
Yeah, I mean, I think all of this is just so interesting because the thing that you said at the end, though, is really a true understanding of something when you're looking at it from the outside can look like memorization, in the sense that when you ask a question, you see the outcome, but how they got to that outcome is the part that you can't necessarily tell from the outside, which is why it seems like memorization seems to be an easy way to kind of display understanding, but you're not actually capturing that. So then I guess when talking about both teachers themselves, curriculas, and then measurements, what are ways in which you can understand whether somebody is understanding something or whether someone is memorizing something?
Very good question. As a teacher, I very often ask myself with my students, because you see, there were some difficult concepts, but I was, let's say, investing a lot of time and given all kinds of problems to students. And when students were answering, I asked myself whether they really understand or they just use that I already asked similar question. And therefore it was necessary to produce new and new types of questions. But I would say that in regular school, in regular situation, you can I wouldn't say that it's very difficult to understand what is going on. Let me cite documents which I was reading again, studying some period, and there are reports of people visiting classes, and there is such a case. So beautiful student, you studied mathematics, and student receive a question, infinitely small. Sequence approaching, converging to zero. Students tells everything beautifully, definition, something, theorems, everything is delivered. Give me an example of infinitely small, asks examiner. 1 million, says student, demonstrating that understands nothing, because infinitely small in analysis, it's a sequence. It's not one small number. It's a sequence, so infinitely many numbers. And I would say that this example is very correct. You a little bit move situation. And typically then memorization, just senseless memorization, fails. You see, it can be something very simple. By the way, it can be, psychologists are doing this. You just rotate your picture in geometry. Or famous discussed in many sources approach. In good old days, in 19th century, even in 20th century, actually even today, students are proving some theorems about triangles and telling accurately that triangle ABC congruent, or they said equal, of course, then to triangle A1, B1, C1, all these things. What teacher did, and yes, today people very rarely are doing it, but then, say, when I was a child, my teacher said, Karp to blackboard, go and prove such and such thing. And yes, any other student did it. What teachers did, they changed letters. Instead of ABC, they wrote MMK. And yes, some students could repeat with ABC, because young head, they memorize, they fail. By the way, if you ask, you can ask question. I mentioned triangles, but you see millions of students in the United States and in the entire world are memorizing that if three sides of one triangle are congruent to three sides of another triangle, then these two triangles are congruent. Ask student, beautiful. And what if only two sides of one triangle are congruent to two sides of another triangle? Are these triangles congruent or not? It's obvious, it's absolutely obvious. Two sides, right? Two sides, and you can do different triangles which are not equal. It's very easy, you understand, right? Like this and like that, it's easy. But you will find that not all students answer, because it makes absolutely no sense to them. They learned two. The guy asks about two. Please take two. Why not? Please, let me make you a favor. And another thing, you see, there are many things like that. I remember it was, you see, a case when I was in position of examiner. I came to exam in one school, and students that was in Russia, and student was proven some theorem about relations between different lines in a three-dimensional space. By the way, parenthetically, let me say that three-dimensional geometry almost never is studied in this country, which is a pretty strange thing, because, by the way, we do live in three-dimensional space, not in the plane. And it would be interesting, we're using this terminology. You can say that, yes, this line is perpendicular to this plane. What does it mean? You need to understand. We're using this, but it's not that there is any cause. Anyway, I came to the class. There was some theorem. Student absolutely beautifully provided a proof. And then I asked him, I gave him 3 pens and said, can you show me? And he could not. He could not, because he had no image behind that. And that, of course, shows that first student did not understand. But honestly, it shows that teacher also did not necessarily the best work possible. Because you need, that's the job, you are trying to tell student mathematical things in different ways. Because people understand not everybody understands in the same way. And it's good to give, let's say, to write a formula, to say in words, to explain visually, to probably tell a story if you can, and so on and so forth, so that it will come in different ways. And it will enrich understanding. So, yes, a student, prospective teacher, generally need to master these techniques.
I mean, I think overall, I mean, I what I'm getting from this conversation, which I feel like is a really helpful addition to what we've spoken about. We've had a few people come and talk about mathematics and curriculum in this season. I think really differentiating, as we've been talking about right now, between understanding and memorization is one key part, and then thinking about how does that then end up influencing the way we teach about things. But I think where we started this conversation was also so interesting, understanding how historically things have changed in terms of how we teach math and the things that we place values on, and the kind of importance of mathematics in developing your ability to create definitions, to reason. I think all of these things have been really helpful. But overall, thank you so much for coming on the show today.
Thank you so much. It was a pleasure. Thank you.
Yeah.
Okay.
I want to say thank you all for listening. I hope you enjoyed this conversation. Season 12 is slowly coming to an end. I think we have almost 10 days left of recording for this season. But apart from that, I hope everything is going well. If you've enjoyed this show, you can find more of us on Spotify, Apple, and YouTube, and on our website, reeducated.org. And if you've liked this conversation and would like to support the show, you can also find us on Patreon. This show truly runs only because of all of your support. And as per usual, stay re-educated.